The modern world likes to believe it stands at the absolute peak of human achievement. Skyscrapers scrape the clouds, satellites orbit the planet, and supercomputers process information at speeds once unimaginable. Yet beneath this confidence lies an uncomfortable truth. There are ancient feats of engineering, science, and craftsmanship that modern technology still cannot fully explain, replicate, or surpass. These achievements were created without electricity, without modern machinery, without digital measurement tools, and often without written technical manuals. And yet, they endure, sometimes more precise, more resilient, and more mysterious than anything built today. Across the ancient world, civilizations achieved results that challenge our understanding of what is possible with limited tools. Massive stones were quarried, transported, and fitted together with tolerances tighter than modern construction standards. Structures were aligned to celestial bodies with astonishing accuracy. Materials were engineered to last thousands of years, resisting erosion, earthquakes, and time itself. These were not isolated miracles. They were the result of knowledge systems that were deeply integrated with nature, mathematics, astronomy, and an intuitive understanding of physical laws that modern science is only beginning to rediscover. Consider the question of scale. Today, when we move extremely heavy objects, we rely on cranes, hydraulics, steel cables, engines, and computer modeling. In the ancient world, entire civilizations moved stones weighing tens, sometimes hundreds of tons, over long distances and elevated them in a place with no visible traces of ramps, cranes, or mechanical debris. The stones of Baalbek in modern-day Lebanon weigh up to 1,000 tons each. Even with modern cranes, lifting and precisely placing such stones would be a major engineering challenge. And yet these blocks were not merely moved. They were set with incredible precision, forming foundations so stable that they have survived earthquakes that destroyed later structures built on top of them. Modern engineers can calculate forces, simulate stress, and test materials in laboratories. But calculations alone do not solve practical problems of execution. The ancient builders did not have digital simulations, yet their structures often outperform modern ones in longevity. The Roman Pantheon, with its massive, unreinforced concrete dome, still stands after nearly 2,000 years. Modern concrete, reinforced with steel, often begins to degrade within a century. Roman concrete, mixed with volcanic ash, becomes stronger over time, especially when exposed to seawater. Scientists today are still studying its chemical composition, trying to replicate a formula that ancient builders mastered through experience and empirical knowledge. Precision is another area where ancient feats remain unmatched. The Great Pyramid of Giza is aligned to true north with an error of only a fraction of a degree. Achieving this level of accuracy today requires laser instruments, GPS systems, and advanced surveying equipment. The ancient Egyptians accomplished it using simple tools, the stars, and an understanding of Earth's geometry that remains astonishing. The pyramid's base is level to within a few centimeters across hundreds of meters. Modern construction projects of similar scale often struggle to achieve comparable precision, even with advanced technology. What makes these feats even more remarkable is that they were not isolated monuments built by singular geniuses. They were part of broader systems of knowledge shared across generations. The builders of Machu Picchu shaped stones so perfectly that not even a blade of grass can fit between them. These stones were cut, transported, and assembled in a mountainous region prone to earthquakes. The result is a city that flexes and shifts during seismic activity rather than collapsing. Modern earthquake-resistant architecture relies on steel reinforcements, dampers, and complex calculations. The Inca achieved similar resilience through stone geometry and placement alone. In ancient Egypt, the scale of organization required to build monumental structures defies simplistic explanations. Quarries were managed, transportation routes were coordinated, labor forces were supplied with food and shelter, and work was synchronized with seasonal cycles of the Nile. This level of logistical sophistication rivals modern large-scale infrastructure projects. Yet it was accomplished without centralized digital planning systems or modern communication technologies. The knowledge existed in the minds of architects, engineers, and workers who understood their environment intimately. Astronomy plays a crucial role in many ancient feats that modern technology still struggles to fully appreciate. Stone circles, temples, and pyramids across the world are aligned with solstices, equinoxes, and stellar events. At sites like Stonehenge, sunlight passes through carefully positioned stones to mark specific times of the year. In Mesoamerica, structures were aligned to Venus cycles with extraordinary accuracy. Tracking planetary movements over decades requires careful observation, record-keeping, and mathematical understanding. Today, computers do this effortlessly, but ancient astronomers achieved similar results through patience, pattern recognition, and a worldview that placed humanity within a cosmic rhythm. Modern science often separates disciplines into narrow fields. Ancient knowledge systems were holistic. Architecture was inseparable from astronomy. Engineering was linked to ritual, symbolism, and natural cycles. This integration may be one reason ancient structures feel so harmonious with their surroundings. They were not imposed on nature, but designed in dialogue with it. Modern technology, for all its power, often prioritizes efficiency and speed over longevity and balance. As a result, many modern structures age rapidly, require constant maintenance, and fail catastrophically when stressed beyond design limits. Material science is another domain where ancient achievements remain difficult to surpass. The steel of Damascus blades displayed patterns and properties that modern metallurgists only recently began to understand. These blades combined hardness with flexibility, capable of cutting through armor without shattering. The exact techniques used to produce them were lost for centuries. Even today, recreations often fall short of the original performance. Similarly, ancient glass, pigments, and dyes sometimes retain their color and clarity after thousands of years, while modern equivalents fade or degrade much more quickly. One of the most unsettling aspects of ancient feats is the apparent absence of trial and error evidence. Many ancient structures appear as if their builders already knew exactly what would work. There are few signs of collapsed prototypes or gradual improvement. This suggests that the knowledge was well established long before the surviving monuments were built. It raises questions about how much earlier civilizations may have developed sophisticated technologies that were later lost due to environmental change, social collapse, or deliberate suppression. Modern technology excels at miniaturization and speed. Ancient technology excelled at permanence and harmony. A smartphone becomes obsolete in a few years. An ancient stone structure can stand for millennia. This difference reflects not just technological capability, but philosophical priorities. Ancient builders often aim to create something eternal, something aligned with the gods, the cosmos, or future generations. Modern society often builds for immediate utility and economic return. Even when modern engineers attempt to replicate ancient feats, they often rely on heavy machinery, power tools, and industrial processes. When stripped of these aids, many modern techniques fail. Experiments to recreate ancient stone-cutting methods using only period-appropriate tools have shown that it is possible, but only with skills that take years to master. This suggests that ancient craftsmanship involved levels of expertise that modern mass production has largely eliminated. The idea that ancient people were primitive is a myth born from technological arrogance. They were not lacking intelligence or creativity. They simply expressed it differently. Their technologies were adapted to their environments, resources, and cultural values. They optimized for resilience, sustainability, and meaning. Modern technology optimizes for speed, scale, and profit. Neither approach is inherently superior, but the ancient one has produced results that continue to challenge us thousands of years later. There is also the question of lost knowledge. Libraries burned, oral traditions faded, and specialized skills disappeared as societies changed. What we see today may be only fragments of a much larger body of ancient science. The surviving monuments may represent the peak of traditions whose foundations are no longer visible. Modern technology, for all its data storage and redundancy, is not immune to loss either. A prolonged disruption could erase vast amounts of digital knowledge in a very short time. When we stand before ancient feats that modern technology still cannot match, we are confronted with humility. These structures remind us that progress is not linear. Knowledge can be gained, lost, and rediscovered. They challenge us to rethink what technology truly means. Is it merely the ability to manipulate matter with machines? Or is it the wisdom to build in harmony with natural laws and long-term cycles? Perhaps the greatest lesson of these ancient feats is not that modern technology is inadequate, but that it is incomplete. We have power without patience, precision without permanence, and speed without stability. The ancient world offers a different model, one where technology was an extension of observation, tradition, and deep respect for the environment. As we continue to push the boundaries of innovation, these ancient achievements stand as silent teachers. They do not mock modern technology, they question it. They ask whether our creations will still stand in 1,000 years, whether our materials will endure, whether our systems are resilient or fragile. Until modern technology can consistently answer those questions, the ancient feats will remain unmatched, not because we lack intelligence, but because we may have forgotten what true mastery once looked like. The deeper we examine these ancient accomplishments, the more they challenge the assumptions at the core of modern technological thinking. Today, technology is often defined by complexity. More parts, more systems, more automation. In the ancient world, technology was often defined by simplicity, refined to perfection. Fewer tools, fewer materials, but an extraordinary understanding of how to use them to their absolute limits. Take ancient road systems as an example. Roman roads stretched across continents, surviving centuries of weather, warfare, and neglect. Many modern roads, built with advanced machinery and modern materials, require constant resurfacing and repair within decades. The Romans layered stone, gravel, sand, and concrete in a way that distributed weight and allowed water to drain naturally. They understood erosion, load-bearing, and maintenance cycles intuitively. Modern engineers know these principles theoretically, yet economic pressures often lead to shortcuts that sacrifice longevity for speed and cost efficiency. Water management is another area where ancient feats remain difficult to match. The aqueducts of Rome transported millions of gallons of water daily across vast distances using gravity alone. No pumps, no electricity, just precise gradients maintained over kilometers. A deviation of even a few centimeters could have stopped the flow. These systems supplied cities with clean water for centuries. Some aqueducts are still functional today. Modern water infrastructure, despite advanced pumps and filtration systems, is highly vulnerable to power outages, corrosion, and system failure. In the ancient city of Petra, water was collected, stored, filtered, and distributed in a desert environment with astonishing efficiency. Channels carved into rock captured seasonal rainfall and flash floods, directing water into cisterns protected from evaporation. This allowed a large population to thrive in a place where modern cities would struggle without constant external supply. Modern desalination plants and pumping systems can achieve similar results, but only with massive energy consumption and ongoing maintenance. Energy efficiency itself is an area where ancient solutions appear surprisingly advanced. Ancient buildings were often designed to regulate temperature naturally. Thick stone walls, strategic orientation, courtyards, and ventilation shafts created passive cooling and heating systems. In hot climates, interiors remained cool during the day and warm at night. In colder regions, structures trapped heat efficiently. Modern buildings often rely heavily on air conditioning and heating systems, consuming enormous amounts of energy to compensate for designs that ignore natural thermodynamics. Sound and acoustics reveal yet another layer of ancient mastery. Amphitheaters like those in Greece and Rome were designed so that a single human voice could be heard clearly by thousands of people without amplification. The geometry of seating, the materials used, and the open-air design worked together to carry sound with remarkable clarity. Modern concert halls rely on digital modeling and sound systems to achieve similar results. Even then, they sometimes fall short of the acoustic purity achieved by ancient builders using nothing more than observation and experimentation. There are also ancient feats that seem to border on the inexplicable. Megalithic sites across the world feature stones carved with precision that rivals modern machining. Flat surfaces, perfect angles, and drilled holes appear in cultures that supposedly lacked metal tools capable of such work. While theories exist, abrasive sand, copper tools, long hours of labor, they often fail to fully explain the consistency and scale of the results. Modern technology can replicate these shapes easily with machines, but doing so manually at that scale remains extraordinarily difficult. Transportation of massive stones is another enduring mystery. Stones weighing dozens or hundreds of tons were moved across uneven terrain, rivers, and mountains. Modern experiments using logs, sledges, and manpower show that it is possible, but only under ideal conditions and with enormous effort. Ancient builders achieved this repeatedly as part of standardized construction processes. This implies not just brute force, but sophisticated planning, coordination, and perhaps techniques that have not survived in historical records. One reason modern technology struggles to match these feats is specialization. Today, tasks are divided among experts who often focus on narrow domains. In the ancient world, master builders were generalists. They understood materials, astronomy, geometry, climate, and human behavior as interconnected systems. This holistic perspective allowed them to design structures that worked seamlessly with their environment. Modern projects often suffer when these domains are separated, leading to inefficiencies and unforeseen failures. Another factor is time. Ancient builders often worked on projects that span generations. A cathedral, temple, or pyramid was not expected to be completed quickly. This allowed for patience, refinement, and the accumulation of experiential knowledge. Modern society demands rapid results. Projects are bound by political terms, budgets, and deadlines. Longevity becomes secondary to immediacy. There is also the issue of sustainability. Ancient technologies were inherently sustainable because they had to be. Resources were local. Waste could not be easily hidden or exported. If a system failed, the consequences were immediate and visible. This forced ancient societies to develop technologies that worked within ecological limits. Modern technology often externalizes its costs, pollution, resource depletion, environmental damage, making systems appear efficient while creating long-term instability. Even medical and biological knowledge from the ancient world reveals surprising sophistication. Ancient surgical tools resemble modern instruments in form and function. Herbal medicines were developed through centuries of observation and experimentation. Some ancient remedies are now being validated by modern science, revealing biochemical knowledge embedded in traditional practices. While modern medicine has advanced dramatically, it still struggles with chronic diseases and antibiotic resistance, problems partly created by over-reliance on technological shortcuts. What truly sets ancient feats apart is not just what was built, but how well it has endured. Time is the ultimate test of technology. Many modern systems have not yet faced this test. We assume progress because our tools are faster and more powerful, but endurance tells a different story. Stone temples still stand while steel and concrete structures crumble. Ancient inscriptions remain legible while digital data becomes unreadable within decades due to changing formats and hardware. This raises an uncomfortable possibility that modern technology may be more fragile than ancient technology, despite its apparent superiority. Complexity creates vulnerability. Systems with many interdependent parts can fail catastrophically when one element breaks. Ancient systems were often robust precisely because they were simple. Gravity-driven water systems do not crash. Stone structures do not require software updates. As we look to the future, these ancient feats may offer more than historical curiosity. They may provide guidance. Architects are rediscovering passive cooling techniques. Engineers are studying ancient materials for sustainable alternatives. Urban planners are revisiting ancient city layouts that prioritized walkability, water access, and climate adaptation. The question is not whether modern technology is capable of matching ancient feats in raw terms. With enough energy and machinery, it can. The real question is whether it can do so with the same elegance, efficiency, and longevity, without exhausting resources or creating instability. So far, the ancient world still holds the advantage. And perhaps that is why these ancient feats continue to fascinate us. They are reminders that human ingenuity did not begin with computers or engines. It flourished long before them, guided by observation, patience, and a deep understanding of natural laws. Until modern technology fully integrates those principles, the achievements of the ancient world will remain not just impressive, but unmatched. As we continue pulling on this thread, an even deeper pattern begins to emerge. Ancient feats were not accidents, nor were they isolated flashes of genius. They were the outcome of civilizations that structured their entire way of life around knowledge preservation, skill transmission, and long-term thinking. Modern technology, by contrast, often advances faster than wisdom can keep up with it. In the ancient world, knowledge was embodied. It lived in the hands of craftsmen, in the memory of master builders, in rituals, apprenticeships, and lived experience. Skills were passed down through years, sometimes decades, of direct mentorship. A stonemason did not simply learn how to cut stone. He learned how stone behaves in heat, cold, moisture, and time. A builder did not just follow measurements. He learned how structures breathe, settle, and age. Modern technology externalizes knowledge into machines, software, and instructions. While this allows rapid scaling, it also disconnects humans from the materials and forces they work with. This disconnection has consequences. When ancient builders made mistakes, they felt them immediately. A misaligned stone meant instability. Poor drainage meant flooding. These feedback loops refined techniques over generations. Modern technology often buffers humans from feedback. Structural weaknesses may not reveal themselves for decades, long after the original designers are gone. Responsibility becomes diffused, and lessons are slower to be learned. One of the most striking differences between ancient and modern feats is the concept of redundancy. Ancient systems often incorporated multiple layers of safety without relying on complex mechanisms. A stone wall might be thicker than necessary, not because calculations demanded it, but because experience suggested it would last longer. Water systems had overflow channels, backup cisterns, and gravity-based fail-safes. Modern systems often aim for optimization, minimum material, minimum cost, maximum efficiency. This leaves little margin for error when unexpected stresses occur. Earthquakes provide a powerful example. Ancient structures in seismic zones often survive where modern buildings fail. The reason is not mystery, but philosophy. Ancient builders accepted movement as inevitable and designed structures to accommodate it. Stones were interlocked, not rigidly bonded. Buildings could sway, settle, and shift without collapsing. Modern construction often resists movement through rigidity, which can lead to catastrophic failure when forces exceed design limits. There is also the matter of scale perception. Ancient builders worked at human scale, even when constructing massive monuments. Measurements are often based on the body, hands, feet, strides. This created structures that felt proportionally harmonious to human experience. Modern technology uses abstract units and digital models, which can produce efficient designs but sometimes lack intuitive balance. The ancient sense of proportion may be one reason their structures feel timeless rather than alien. Another overlooked factor is the role of ritual and meaning. In the ancient world, building was often sacred. Temples, monuments, and even infrastructure were infused with symbolic purpose. This imbued the work with care and attention that went beyond function. When a structure represents cosmic order, divine presence, or ancestral legacy, shortcuts become unthinkable. Modern technology is largely secular and utilitarian. Efficiency often outweighs meaning, and this can subtly erode craftsmanship. We also underestimate ancient mathematical knowledge because it was expressed differently. Not all mathematics was written in symbols. Much of it was geometric, visual, and embodied in construction itself. Ratios, angles, and proportions were encoded in layouts and alignments. The fact that these principles still work and still inspire modern architects suggests a level of mathematical sophistication that does not require modern notation to be real. Timekeeping is another domain where ancient achievements rival modern technology. Ancient calendars tracked solar, lunar, and planetary cycles with astonishing accuracy. Some ancient systems accounted for leap years, precession, and long-term astronomical drift. This required observation over centuries, careful correction, and intergenerational knowledge continuity. Modern atomic clocks are more precise, but they depend on fragile infrastructures. Ancient timekeeping systems endured through social collapse, conquest, and environmental change. Even agriculture reveals ancient feats modern technology struggles to replicate sustainably. Terraced farming in mountainous regions prevented erosion, retained water, and created microclimates. These systems are still productive centuries later. Modern industrial agriculture produces higher short-term yields but often depletes soil, pollutes water, and requires constant chemical input. Ancient methods optimize for continuity rather than maximization. When modern technology attempts to improve ancient systems, it often unintentionally degrades them. Concrete poured over ancient stonework traps moisture and accelerates decay. Heavy machinery damages foundations designed for distributed loads. This reveals a fundamental misunderstanding. Ancient systems were not primitive versions of modern ones. They were optimized for entirely different priorities. Another reason modern technology cannot fully match ancient feats is institutional memory. Ancient societies embedded technical knowledge in cultural practices. Festivals marked agricultural cycles. Myths encoded astronomical events. Architecture reinforced cosmological understanding. Knowledge was not confined to specialists. It was shared across society. Modern knowledge is often siloed in institutions, patents, and proprietary systems. When institutions fail or priorities shift, knowledge can vanish rapidly. There is also the question of resilience under collapse. Ancient technology often remained functional even when political systems fell. Roads, aqueducts, and buildings continued to serve populations long after empires disappeared. Modern technology is deeply tied to centralized systems, power grids, supply chains, digital networks. When these fail, functionality can collapse almost instantly. This fragility stands in stark contrast to ancient robustness. As we look at ancient feats that modern technology still cannot match, it becomes clear that the comparison is not simply technical. It is philosophical. Ancient technology was shaped by limits: limited energy, limited materials, limited speed. Those limits force creativity, efficiency, and harmony. Modern technology often removes limits, but in doing so, it can lose direction. The ancient world reminds us that mastery is not about domination of nature, but cooperation with it. Stones were chosen for their natural properties. Buildings followed the land rather than reshaping it entirely. Water was guided, not forced. These principles are now being rediscovered under the banner of sustainable design, but they are thousands of years old. Perhaps the most humbling realization is that ancient people did not see themselves as more advanced or superior. They saw themselves as caretakers of knowledge inherited from those before them. Progress was measured in continuity, not disruption. Modern technology celebrates disruption, often at the expense of stability. As long as modern civilization prioritizes speed over endurance, convenience over resilience, and profit over permanence, ancient feats will continue to stand apart, not as relics of a lesser age, but as evidence of a different kind of intelligence, one that modern technology has not yet fully reclaimed. When all of this is taken together, a sobering realization begins to settle in. Modern technology is extraordinary at expanding capability, but ancient technology was extraordinary at preserving balance. That balance between human ambition and natural law may be the missing ingredient that explains why so many ancient feats remain unmatched. Ancient builders understood that time was not an enemy to defeat, but a force to work with. Structures were designed to weather, to settle, to age gracefully. Stone was allowed to crack in controlled ways. Wood was chosen for how it expanded and contracted. Metals were used where flexibility was needed, not simply where strength was desired. Modern materials often fight against natural processes, relying on chemical treatments, reinforcements, and maintenance to delay inevitable decay. Ancient materials embraced those processes, channeling them instead of resisting them. This understanding extended beyond construction into the broader technological mindset. Ancient tools were often deceptively simple, yet optimized through centuries of refinement. A hand tool, shaped by generations of use, can outperform a poorly designed machine in skilled hands. Modern tools emphasize power and speed, often at the cost of precision and tactile feedback. When machines fail, the knowledge to replace them manually is often gone. There is also the psychological dimension of ancient feats that modern technology struggles to replicate. Ancient societies cultivated patience on a scale that is almost alien today. Waiting decades to complete a project was not seen as failure. It was seen as commitment. The builders of monumental structures often knew they would never see the final result. Their work was an offering to the future. Modern technology is deeply rooted in short-term gratification. Products are designed for rapid turnover, not generational inheritance. This difference in mindset influences outcomes in ways that are not immediately obvious. When something is built to last only a few decades, compromises feel acceptable. When something is built to last forever, every decision carries weight. Ancient feats reflect that gravity. They feel deliberate, measured, and confident, qualities that are difficult to mass-produce with modern systems driven by speed and competition. Even failures in the ancient world were instructive in ways modern failures often are not. When an ancient structure collapsed, it was a public and permanent lesson. The ruins remained as warnings and teachers. Modern failures are often hidden, patched, or erased. Software bugs are fixed silently. Structural flaws are covered or demolished. The feedback loop is weaker, and collective learning suffers. The modern assumption that technology naturally improves over time is also challenged by ancient achievements. History shows that technological capability can plateau, regress, or vanish entirely. The loss of Roman concrete, Greek fire, and advanced ancient metallurgy are reminders that knowledge is fragile. Modern technology depends heavily on continuity, electricity, data centers, global trade. Remove those, and much of modern capability evaporates almost instantly. Ancient technology, by contrast, was often low energy and self-contained. It did not require constant external input to function. Gravity-fed systems worked as long as gravity existed. Stone structures stood as long as stone endured. This independence from complex supply chains is a form of sophistication that modern technology rarely achieves. Another overlooked factor is adaptability. Ancient systems were designed to be repaired, modified, and reused. Stones from older structures were often repurposed without compromising integrity. Techniques could be adjusted locally based on available materials and conditions. Modern technology is often rigid. Components are standardized, proprietary, and difficult to repair. When one part fails, the entire system can become obsolete. As climate challenges intensify, this adaptability becomes increasingly relevant. Ancient societies faced environmental changes without fossil fuels, satellites, or predictive models. They responded with architectural shifts, agricultural adaptations, and water management innovations that allowed survival in harsh conditions. Modern technology has greater predictive power, but its solutions often rely on high energy consumption and centralized control, making them vulnerable to disruption. The emotional impact of ancient feats is also telling. Standing before an ancient structure often inspires awe not just because of its size, but because of its restraint. There is a sense that nothing is wasted, nothing is excessive. Every stone has a reason to be there. Modern megastructures can impress, but they rarely evoke the same timeless respect. They feel temporary even when massive. This is not because modern engineers lack skill. It is because modern systems are rarely allowed the conditions necessary for timelessness. Economic pressure, political cycles, and consumer expectations shape outcomes as much as physics does. Ancient builders answered to different forces: tradition, cosmology, ancestry, and long-term survival. When modern technology fails to match ancient feats, it is often because it is solving a different problem. Modern civilization asks, how fast can we build? Ancient civilizations asked, how long will this stand? Modern technology asks, how much can we extract? Ancient technology asked, how do we sustain? These are fundamentally different questions, and they produce fundamentally different results. The danger lies in assuming that newer automatically means better. This assumption blinds us to lessons that ancient feats still offer. As modern societies confront resource limits, environmental stress, and systemic fragility, the ancient approach begins to look less like a relic and more like a blueprint. The truth is not that modern technology is inferior, but that it is incomplete. It excels at expansion, but struggles with endurance. It amplifies power, but often neglects wisdom. Ancient feats endure because they were born from a culture that understood limits, respected cycles, and valued continuity over dominance. Until modern technology learns to value those same principles, not as nostalgic ideals, but as engineering fundamentals, the ancient world will continue to outshine us in the one category that ultimately matters most: the ability to create something that truly lasts. At this point, the comparison between ancient feats and modern technology stops being about tools and starts being about worldview. Technology is not just what we build, but why we build it. And this is where the ancient world and the modern world diverge most sharply. Ancient civilizations operated with an awareness of deep time. They understood that human life was brief, but the land, the sky, and stone endured. Their greatest achievements were designed to anchor human existence within that larger timescale. Monuments aligned to stars that would return thousands of years later. Calendars tracked cycles longer than any single lifetime. Structures were placed where they would interact with light, shadow, wind, and water in predictable patterns across centuries. This required a patience and humility that modern technological culture rarely cultivates. Modern technology, by contrast, is dominated by short horizons. Economic cycles, political terms, product lifespans, and rapid innovation all compress time. Even our language reflects this urgency. Faster, newer, bigger, smarter. But speed has a cost. When technology evolves too quickly, it leaves no room for refinement. Ancient techniques improved slowly but deeply. Each generation added marginal gains to systems already proven by time. Modern systems are often replaced before their weaknesses are fully understood. This is one reason ancient feats feel so complete. They're not beta versions. They're finished ideas. A stone temple or aqueduct represents the final expression of centuries of accumulated knowledge. Modern infrastructure often feels provisional, designed with the expectation that it will be upgraded, patched, or replaced. Permanence is no longer the goal. Adaptability to rapid change is. There is also a fundamental difference in how failure was treated. In ancient societies, failure carried existential consequences. A collapsed dam meant famine. A A failed harvest meant starvation. This forced extreme caution and conservatism in technological decisions. Only what had been tested, observed, and trusted was scaled up. Modern technology often embraces failure as part of innovation. While this accelerates progress, it also normalizes fragility. Systems are allowed to fail because recovery is assumed to be possible until it isn't. Another critical distinction lies in energy. Ancient feats were built in an energy-constrained world. Human labor, animal power, wind, water, and gravity were the primary sources. This forced efficiency at every level. Shapes, materials, and methods were optimized to minimize wasted effort. Modern technology exists in an energy-abundant paradigm, at least temporarily. Fossil fuels and electricity mask inefficiencies. When energy is cheap, inefficiency is tolerable. When it is not, systems collapse quickly. This dependence on high energy input is one of the reasons modern technology struggles to match ancient feats in resilience. An ancient bridge does not need fuel. An ancient water system does not need a power grid. Modern equivalents often do. Remove the energy source, and functionality vanishes. Ancient systems degrade slowly. Modern systems fail abruptly. The social structure supporting ancient feats also mattered. Skilled labor was respected and central to society. Craftsmen were not interchangeable parts of an industrial machine. They were repositories of critical knowledge. Their expertise shaped outcomes directly. Modern technology often distances decision-makers from makers. Designs are created digitally, manufactured elsewhere, assembled by others, and used by people who have no role in their creation. This separation dilutes responsibility and understanding. Ancient feats also benefited from continuity of purpose. Sacred sites were maintained for centuries. Cities grew organically around stable cores. Infrastructure was integrated into daily life rather than hidden or outsourced. Modern technology often prioritizes modularity and abstraction. Systems are designed to be invisible until they fail. This invisibility breeds neglect and underinvestment, leading to rapid decay. There's a deeper irony here. Modern technology prides itself on precision, yet ancient feats often demonstrate a more profound accuracy, not in decimal places, but in alignment with reality. Ancient builders did not fight gravity. They worked with it. They did not deny erosion. They planned for it. They did not ignore climate. They designed around it. Modern technology often attempts to override these forces, expending enormous energy to maintain artificial conditions. This is why ancient structures feel inevitable, as if they belong exactly where they stand. Modern structures can feel imposed, even when impressive. The difference is subtle but powerful. One emerges from its environment, the other dominates it. Over time, the environment always wins. As modern science continues to uncover the principles behind ancient feats, a quiet reversal is taking place. Engineers study ancient domes to improve modern ones. Material scientists analyze ancient concrete for clues to durability. Architects revisit ancient city layouts for climate resilience. What was once dismissed as primitive is now recognized as sophisticated in ways modern technology overlooked. Yet knowledge alone is not enough. The missing element is cultural. Ancient feats were possible because entire societies supported the values that produced them. Long-term thinking, respect for tradition, and acceptance of limits were not optional. They were embedded in daily life. Modern technology exists within cultures that reward speed, novelty, and disruption. Until those incentives change, the results will continue to differ. In the end, the reason modern technology still can't match these ancient feats is not because we lack intelligence, tools, or data. It is because we are solving different problems under different assumptions. Ancient technology sought permanence in an uncertain world. Modern technology seeks control in a complex one. The ancient world left behind structures that still function, still inspire, and still challenge our understanding. They do not do so loudly. They do not advertise their brilliance. They simply endure. And in that endurance lies their greatest achievement. As long as modern civilization measures success by speed rather than survival, by growth rather than balance, and by power rather than wisdom, these ancient feats will remain beyond our reach, not as mysteries of a lost age, but as mirrors reflecting what modern technology has yet to relearn. Even after acknowledging all of this, one final layer remains, perhaps the most unsettling of all. Some ancient feats do not merely outperform modern technology in durability or elegance. They challenge our assumptions about what ancient people were even capable of knowing. Across the world, ancient structures encode information with a precision that suggests advanced understanding of mathematics, astronomy, and Earth itself. Measurements repeat across cultures separated by oceans and millennia. Ratios appear that match planetary cycles, Earth's dimensions, and harmonic principles found in nature. Whether these patterns were intentional or emergent, their consistency forces modern researchers to reconsider the intellectual depth of ancient civilizations. For example, many ancient monuments seem to reflect an understanding of Earth as a sphere long before this idea was formally accepted in modern history. Distances between sites, orientations, and proportions align with latitude, longitude, and geodetic principles. Achieving this requires not just observation, but abstraction, the ability to model the world conceptually. Modern technology relies on satellites to do this. Ancient cultures did it with the sky, the land, and time. What makes this more extraordinary is the lack of written technical explanation. Modern technology depends on documentation, schematics, and formal education. Ancient knowledge was often transmitted orally or symbolically. This means that much of it was never meant to be read. It was meant to be practiced. Geometry was learned by building. Astronomy was learned by watching the sky night after night. Engineering was learned by feeling materials under stress. This kind of knowledge leaves fewer records, but deeper competence. Modern science sometimes struggles to accept this because it challenges the idea that progress must be linear and cumulative. The existence of ancient feats that modern technology still cannot fully explain suggests a more complex reality. Knowledge can rise, fragment, and reassemble in different forms. What we call advanced may simply be what we currently value. There's also the uncomfortable question of loss. If ancient people could achieve such feats, what else did they know that is now gone? Environmental collapse, war, conquest, and cultural disruption have erased entire knowledge systems before. The burning of libraries, the suppression of traditions, and the breakdown of apprenticeship chains did not just destroy information. They severed continuity. Modern technology assumes data preservation equals knowledge preservation. Ancient history shows that this is not always true. This is especially relevant today. Modern knowledge is stored digitally, dependent on electricity, hardware, and compatibility. Ancient knowledge was stored in practices, landscapes, and monuments. One survives blackouts, the other does not. The irony is striking. The more advanced our technology becomes, the more fragile its memory may be. Ancient feats also force us to reconsider intelligence itself. Intelligence is often measured today in terms of computation, speed, and abstraction. Ancient intelligence was contextual. It understood specific places deeply. It optimized solutions locally rather than universally. A temple, road, or irrigation system was not meant to work everywhere, only where it stood. Modern technology strives for global scalability, sometimes at the cost of local effectiveness. This difference explains why ancient systems often feel perfectly adapted, while modern systems feel generic. One is rooted, the other is portable. Portability brings power, but roots bring resilience. When conditions change, rooted systems can adapt organically. Portable systems often require replacement. The greatest misconception may be that ancient feats represent a peak that humanity somehow fell from. That is not the full truth. Humanity did not lose intelligence. it shifted priorities. Modern technology has achieved wonders ancient people could not imagine, but it has done so by trading depth for breadth, endurance for speed, and wisdom for convenience. The ancient world reminds us that technology is not destiny. It is choice. It reflects what a civilization values, fears, and hopes to preserve. Ancient feats endure because they were built to matter beyond their makers. They were gifts to the future, not products for the present. Modern technology is still young. It has not yet faced the full test of time. 1,000 years from now, very little of today's digital world may remain. What will endure are things that require no power, no updates, no networks, only gravity, material, and form. In that future, ancient stone may still speak more clearly than modern code. So when we ask why modern technology still can't match these ancient feats, the answer is not hidden in missing tools or secret techniques. It lies in perspective. Ancient builders worked as if the future was watching. Modern technology often works as if the future will adapt. Until that changes, until modern civilization builds not just for function, but for memory, meaning, and survival, the ancient world will continue to stand ahead of us in the one arena no technology can shortcut: time. There is one final realization that brings everything into focus. Ancient feats endure not because ancient people were magically gifted or technologically superior in a modern sense, but because they understood something fundamental that modern civilization often overlooks. Technology is only as powerful as the values that guide it. Ancient societies did not separate technology from responsibility. Every major technological decision carried moral, environmental, and social weight. To alter a river, raise a monument, or reshape land was an act with spiritual and communal consequences. This created restraint. Not everything that could be built was built. Not every idea was pursued. Modern technology operates under a different assumption, that if something can be done, it should be done. This shift alone explains much of the gap between ancient endurance and modern fragility. In the ancient world, limits were teachers. Scarcity refined skill. Danger sharpened judgment. Uncertainty encouraged observation. Modern technology often treats limits as obstacles to be eliminated rather than signals to be respected. When limits disappear, so does the discipline they create. The result is power without proportion. This is why ancient feats often feel calm rather than aggressive. They do not scream dominance. They do not overwhelm the landscape. They sit within it, balanced and deliberate. Modern technology often seeks to announce itself. Bigger towers, faster machines, louder signals. But noise is not the same as strength. Ancient achievements whisper, and yet they're still heard thousands of years later. The durability of ancient feats also exposes a quiet failure in modern thinking. The belief that maintenance can replace wisdom. Modern systems are often designed with the assumption that problems will be fixed later. Ancient systems were designed to avoid problems in the first place. Maintenance existed, but it was minimal because the core design respected natural forces instead of fighting them. Even ancient failures were instructive in a way modern ones rarely are. When an ancient dam failed, the ruins remained. The lessons stayed visible for generations. Modern failures are often erased, rebuilt, or digitally forgotten. Society moves on without fully absorbing the warning. This erodes collective learning over time. Ancient feats also reveal a profound respect for inheritance. Knowledge was not owned, it was stewarded. Builders did not innovate for personal fame. They contributed to lineages of technique older than themselves. Modern technology celebrates individual disruption. Innovation is rewarded when it breaks from the past, not when it preserves continuity. This creates rapid change, but it also severs roots. When continuity breaks, knowledge becomes shallow. Techniques lose context. Skills become automated. People know how to use systems, but not how they work. Ancient people knew both. Their technology was transparent. You could see how it functioned. You could feel it. Modern technology often hides its complexity behind interfaces. When it fails, users are helpless. This is not nostalgia. It is diagnosis. Ancient feats still challenge modern technology because they were not designed to impress the present. They were designed to survive the future. Modern technology often does the opposite. It impresses now and decays later. Until that inversion is corrected, the comparison will always favor the ancient world in matters of endurance. The lesson is not to abandon modern innovation, but to mature it, to slow it where necessary, to ground it where possible, to ask not only what can we build, but what should endure. Ancient civilizations asked that question constantly, even if unconsciously. Their answers are still standing. Stone by stone, alignment by alignment, ancient feats testify to a civilization mindset that valued permanence over novelty. They prove that intelligence does not require electricity and mastery does not require machines. It requires attention, patience, and respect for reality as it is, not as we wish it to be. Modern technology has not yet failed completely. It still has time to learn. But until it rediscovers the ancient principles of restraint, harmony, and long-term thinking, it will continue to excel in the short term and fall short in the long one. And that is why, even now, surrounded by screens, engines, and algorithms, we still stand in awe before ancient stone and quietly admit a truth that technology alone cannot hide. They built for forever. Modern technology appears more advanced than anything humanity has ever created, yet ancient civilizations achieved feats that still challenge our ability to explain, replicate, or surpass them. These achievements were not accidents or myths, but the result of deeply refined knowledge systems built on observation, patience, and long-term thinking. Ancient builders moved massive stones, aligned structures to celestial events, engineered materials that strengthened over time, and constructed cities and infrastructure that have survived thousands of years, often without electricity, machinery, or written technical manuals. Their technologies were simple in form, but profound in understanding, working with gravity, climate, materials, and natural cycles rather than against them. The key difference is not intelligence or capability, but priorities. Ancient technology was designed for permanence, resilience, and harmony with nature. Modern technology is designed for speed, efficiency, scalability, and short-term success. Where ancient systems were low energy, self-sustaining, and robust, modern systems are complex, energy-dependent, and fragile when disrupted. Ancient knowledge was holistic and embodied, passed through generations of skilled practice rather than abstract documentation. It valued continuity over disruption, limits over excess, and survival over convenience. As a result, ancient structures endure while many modern systems rapidly degrade or become obsolete. These ancient feats reveal that progress is not linear and that advanced knowledge can be lost as easily as it is gained. They challenge modern civilization to rethink what technology truly means, not just power and innovation, but wisdom, restraint, and longevity. Until modern technology learns to build with the same respect for time, nature, and future generations, the achievements of the ancient world will remain unmatched, not as mysteries of the past, but as enduring lessons for the future. If this exploration changed the way you see the ancient world and modern technology, subscribe for more deep dives into forgotten knowledge, lost civilizations, and a mysteries history still hasn't explained. New videos every week. Stay curious and don't miss what comes next.